Okay, welcome to your classwork 11. I think this is your second last classwork on transition pieces. Let's look at the question here. We've given us the front view and top view of this time of a grain hopper. You can see that it's made of two sections, one small circular section, 300 in diameter, and then it goes out to a sort of a combination of a rectangular section with a semicircle on the front here. Looking down the solution certainly gives you a bit more idea about what it might look like. So this time we've got to make enough equal sides of this circle and also this profile here, or the section here. So if we go by our last drawing where we made this circle into 8 by using the square first and then putting the fillets on, we might be able to do the same. So we know there's one point here, so this could be one edge, 2 for the fillet, 3, 4, 5 for a small flat here, 6, 7, and then 8 for that small fillet there. So it will give us 8 edges as well, which would match the top there. So with that in place, let's I suppose go across to Creo and see if we can create that. We might start with this 300 square one first, I think. Yeah, we'll do that because that's the only thing that's symmetrical. Okay, so let's go to Creo, set your working directory as you normally would do, File, New, Sheet Metal, remember, and this time it's called the grain hopper, underscore, modeled by you of course, and as usual go to Shapes and click on the Blend tool. Click on the Section tab and let's define this first section. So I'm going to select this horizontal plane here and click Sketch. And as we normally do, start off with some center lines so that we can get things with some symmetrical constraints. Then we use our rectangle tool, click once, drag, wait for the arrows, drag down, wait for the red arrows and click. Okay, so this is going to represent this circular feature of 300 in diameter, so it's 300 long. So back to Creo, select tool and change our sizes to 300. And while we're there, rather than change this to 300, let's use the equals tool. Click on the first one, click on the second one, so they stay the same. At that point, I'd also use my select tool, select the 300, right click, and lock it so it cannot change in size. So I've got a lot of constraints holding that in that position. It's really important you do that because things start to get a little bit haywire later on as you do. Alright, so now we need to trim the edges, or not trim, sorry, I should say fillet the edges. Use your fillet tool, and I'm going to click sort of about halfway along here. You'll notice it gives you a default to a larger fillet. 1, 2, 3, and 4. Equals tool as usual to make all the fillets all equal to each other. E1, E1, and E1. And the last thing to do, of course, is to change this to the right size. Let's pull that out there. So what are we going to make this fillet? Back to the drawing. 300, so 150 would be a radius. So if we go for, say, 148, see what that looks like. 150, 148. And that looks pretty good. Yeah, we've got a small flat and then the rest of our fillets looking good there. Okay, and before we click OK, let's take special note. The start point is the left hand side at the top. Remember, we've got to make the same start point on the section above. Okay, we're happy with that section, so we can accept that by clicking on the green tick. And then of course go to Sections tab again and let's sketch the section. And let's go have a look at the second section. Alright, so if we're going to draw this one, I suppose we've got a rectangle with a semicircle, or we could take it this way. We could say to ourselves, this is really one large square that is 700 millimeters in square, coming off this back edge here. And we could fillet this front edge, and small fillets here and here. And that's basically just a square with fillets again. So 700 by 700, and it is symmetrical about this center line and that center line there. It's probably not a bad idea. We might actually put those center lines in, and we'll see if we can. So that would be to this center line down from the top would be 150. Let's see if we can do that. So back to create, center line, and just placing one down the middle to start with. And this other one's going to be snapping to, let me have a look here. I want to draw this center line here. So that's going to be 350 millimeters below this top edge, which is going to be 150. So it's basically going to be 100, no, what's that, 350, 175 to the center. I think that makes sense. So center line again, click once, click twice, and then use your constraint tool, your select tool. Oh, let's mark them all around, so this needs to be down there, sorry. So that one needs to be 175, I do believe. Yeah, that's it. So 175 from the original center line down, and that one there. So we've got two center lines now that we can now to get things symmetrical around. So back to your rectangle tool, and click out here somewhere in space. Try to get it, you know, almost in line with that. Wait for the red arrows, and wait for the red arrows, and let's constrain like we did before, 700. Use the equals command again, equals constraint I should say, 1, 2. And the other thing we need to do is get the one of these positions in the right position, or one of these edges in the right position. Let's have a look here. So we've got 175 to there. We also need to have a distance from this edge to perhaps this center line. So I'm going to use my normal tool, click on this edge, click on my center line, center mouse click, and you can see here it's asking us for, oh, there's a conflicting constraint. Okay, it looks to me like I've made an error with my length here. So my positioning of my center line here is slightly out. So I'm just going to undo that. What have I done wrong there? So 700. Looks like that should be 200 by the looks of it. Yeah, okay, so I had my calculations are slightly out there. So 200 millimeters from this center line to that one, sorry. And that's looking better. Yes, overhanging, let's just check. Yes, we can see that's in the same position. And around it goes. Yeah, that's looking much better. So 700 by 700 and 300, we'll just check that. 7 by 7, and we knew this one below was 300. That's better. So 200 millimeters from the center line of that one. Okay, let's just use our fillet tool again. One down here, 1, 2, 1, 2, and while we're there, we'll do the small fillets as well. 1, 2, 1, 2. This time though, we're going to only make these two at the top equal, 1 and 2, and realistically those fillets only need to be small, so they could probably be something in the lines of, oh gee, even right down to say 2 mil probably. Okay, that's interesting. And the one down the bottom here, so we might just grab that and that. Some crazy constraints have just sort of popped across my page. I'm just moving them out of the road so I can see what's going on. That's still looking dimensionally okay. And of course this front here is going to be, well, almost 350. Let's make it say 348, something like that. So let's constrain these two, 1 and 2. And then let's of course change it from 68, select tool might help, to being, what did I say, 350, or say 348, so it gives a little flat, and enter. Oh. Okay, that's looking pretty good at the moment. Yes, okay, we've got 1, 2 edges, 3, 4, 5, 6, 7, and 8. So that's 8 edges in total. We've got 8 edges on the top section and 8 edges on the bottom section. That start point, I'm not too sure where that is, so let's just check OK and see what happens. And look at that, fantastic. So the start point's gone in the correct position, no twisting evident. And the last thing to do then is to check the height. And we can see here it's a distance of 300 millimeters in height. So let's just check that height. We can type it in here, of course, 300, enter. And we'll just zoom in a bit. That looks good. And check OK. 1 mil thickness, of course. Oh, I've got an error somewhere. Okay, now if we get this error popping up, it could mean that this, see how these are highlighted in pink here? 1, 2, 3, 4. Chances are that's where the error is, and it's probably got something to do with this small 2 mil radius. That radius might be too small for the size of the material that we're trying to bend. So in that case, I'm going to hit done. I'm going to go back to my blend, right click on blend, edit definition. I'm going to go back to the sketch that I drew that on, so I need to go to section, section 2, and back to sketch. And I'm going to edit those two the fillets, rather being 2, make that 5 perhaps. And then click OK again. Still OK. Click OK to the blend, and yes, now we're good. No more pink lines. So that was too tight a curve in there with the 2 mil, so I've just made that 5 mil instead. Good, okay, that's looking good. Now we've got to rip it and then unfold it, and then as usual put it into 2D. So the shortest edge, if we have a look here, would be this edge at the back here. Split it down there. So using your rip tool, click on the arrow, sketch rip. Select the work plane that you're going to be sketching the line on, and using our line tool, snapping to one of these axes, click once, twice, and check OK. Yep, that's where we want to rip. And of course the last thing then is just hit the flat pattern tool. Bang, off it goes. Fantastic. That's looking good. And then let's just give it a new front and top view definition. So we'll use these two surfaces here. So it's under view, named views, reorient. So we're going to reorient a new view. It's asking us for a front view, so I'm going to click this surface here. And it's asking me to select a top view, so I'm going to select this surface here if I can get it. And zoom fit that. And now we can see here's our new view. So we need to save that, remember? And I tend to call it, in graphical terms, this is a development. That might help, spell it correctly. And save that, OK to that. And then we can see, when I go now to name views, there's development, I'm looking directly down 90 degrees. Now just like our other drawings, you need to then save this as a copy, and we're going to call this one drone underscore hopper underscore 3D. OK, OK. Then we're going to open up that one we just saved, so file, open the 3D one up, and then just delete the flat pattern. Yes, yes, one, and it's back to 3D for us. And then save that so we don't forget about it. And then use your tool up here to swap back to the original. Make sure you save that. So we've got two files that we're ready to then bring into the drawing mode. So this is basically exactly the same as all the drawings we've done so far, guys. So I'll just do this really quickly. File, new, drawing, grain hopper again. Empty with format. Go get the detail format like you normally do. Model it by yourself. Drawing number 1, class 12, material, let's just call it sheet. Usual story, you can go to drawing model up here, and one of those is going to be in active memory, so I'm just going to right click, insert general view, and then OK, and then left click, and we can see it's the 2D one, so I'm going to click on development, Scale's obviously way too small, so let's click on scale. Wow, that is small. Let's just try 0.1 to start with. Probably a bit bigger. I might go 0.2. Maybe a bit big. Let's go 0.15. Apply. Okay, I can live with that. Let's turn those planes off. Zoom in, zoom out. Yep, that's cool. And of course, under view display, make sure that you turn your tangent edges to being center lines. And now you've got fold lines. So if this was to be folded up by a sheet metal worker or someone, they could fold it up. Close to that, and then we need to add the other drawing model. So drawing model, add model, go find the 3D part, then set the model. So just bring that over a bit, stretch this out. Select the 3D model, click on done, right click, insert general view, OK, left click, there it is. What scale did we use? It was 0.15, wasn't it, I think? And OK, and apply and close. Yep, that's looking good. Something I haven't thought of doing, I wonder if we could do the tangent edges on this one too, whether we'd seal the folds. That might be a bad idea. View display, center lines. Yeah, that looks pretty good actually. Gives us the idea of all those fold lines as well. Okay, and there's no need to make that black and white because when we do PDF it'll black and white it anyway. So let's go then File, Save as a drawing, and then File, Save as, hover over that for a sec, quick export, off it goes, creates the PDF for us and gives us the preview. Now in days gone by you'd have dimensions all over this and all sorts of things, but we just send this straight off now as a 3D file off to the manufacturer or even the Fab Lab, and it'd cut that out of a piece of sheet and we could fold that up to the exact size. Actually, that's not a bad idea. I might send this file off to Mr. Oswald and he can cut out for us on the new laser cutter. Okay guys, that's the second last classwork. Go for it.